When his trusted John Deere engine died right before spring planting, every official dealer turned their back on him. Refusing to let crushing debt ruin his family farm, Ed made an unheard-of gamble, fitting a new Holland diesel into a green chassis. Would this mechanical defiance save his legacy, or destroy everything he worked for? The engine does not fail dramatically. It does not seize in the middle of a quarter section during peak harvest, with a crop standing and a dark weather front closing in from the west. That is the version of mechanical failure that gets told in stories later to make a drastic decision seem inevitable. On a working farm, true mechanical failure usually arrives far more quietly. It happens gradually across a season and a half of subtle signals that an operator who knows his equipment can read without ever connecting a single diagnostic tool. It communicates in tiny progressive shifts, a slightly longer crank on cold mornings, a soft metallic tick hidden beneath the steady chatter of the valve train, and a faint troubling drop in oil pressure once the iron block reaches full operating temperature under load. These signals repeat in progressively clearer language until the final spring morning, when the starter engages. The flywheel turns over 3 times, the cylinders catch briefly with a hollow rasp, and then everything stops. The sound inside the enclosed cab carries a flat, unyielding finality, a dull metallic quiet that tells the man sitting behind the wheel, before he has even checked a single gauge or lifted the heavy green hood, that the long conversation between him and this engine has come to an end. He has worked these 600 acres of grain ground for 26 years, and this John Deere utility tractor has been the backbone of his daily operation for 19 of them. He bought it used at a price that fit a realistic operating budget, knowing its mechanical reputation made it a defensible investment rather than a compromise. Every single hour on that machine was backed by quiet discipline. On the shelf above his shop workbench sits a thick, oil-stained binder documenting every service interval across those 19 years. Written in his own steady handwriting on yellowed pages are exact records of oil changes, filter replacements, hydraulic fluid flushes, and seasonal valve adjustments, complete with part numbers neatly noted in the margins. It is the physical record of an operator who believes a machine's documented history is just as critical as its current mechanical condition. But even meticulous care cannot halt the slow, relentless erosion of moving parts, and the accumulative hours on the original power unit have finally reached their limit, leaving him with a silent tractor and the heavy weight of an approaching planting season. The compression test results from the previous autumn had made the reality unavoidable. When the local diesel technician pulled the injectors and threaded the gauge into each cylinder, the needle bounced weakly, settling on numbers far below factory specifications. Neither man said anything for a long moment. They simply looked at the gauge face in the cool autumn air of the shop before the technician picked up his clipboard and wrote his formal recommendation. The power unit required a complete overhaul or total replacement before the next working season if the tractor was to remain in service as a primary field machine. He brought the inspection report into the house, laid it flat on the wooden kitchen table, and sat with it over 3 long evenings, working through the numbers until the financial reality was completely transparent. Rebuilding the original John Deere engine through an authorized facility, using genuine factory internal components, was the most straightforward path, but the formal quotes he received were staggering. The total cost for parts, specialized machining, and certified assembly labor reached a figure that forced a cold comparison against the tractor's current market value. Spending that amount of capital on a 19-year-old machine meant investing significantly more than the entire tractor would be worth once the work was finished. It is the brutal arithmetic that forces so many well-maintained utility machines off active farms every year. The equipment market values a machine purely on age, recorded operating hours, and cosmetics, entirely blind to the decades of meticulous service history documented in a shop binder. While a factory remanufactured crate engine presented a slightly lower upfront cost than a full custom overhaul, it still required an immediate cash outflow that his operating account simply could not absorb heading into spring. Siphoning that much working capital out of the farm right before buying seed, fertilizer, and fuel would create an unacceptable cash flow strain across the entire planting window. Furthermore, part suppliers quoted an 8 to 12-week delivery backlog for a crate unit, placing its arrival past the edge of the spring fieldwork deadline. Sitting under the dim kitchen light with his figures spread out before him, He was left facing a critical gap between what his farm required and what traditional commercial channels could provide. The solution arrived not through formal commercial channels, but through a chance encounter at a regional farm machinery consignment sale in mid-February. Snow was packed hard against the gravel lot, and a bitter cold wind blew through the open doors of the main storage warehouse, where rows of parted-out equipment, salvaged axles, and used components were arranged on timber pallets. While walking through the back aisles and talking with the auction representative about available power units, the man mentioned a complete New Holland 4-cylinder diesel engine resting on a heavy oak skid near the back wall. It had been carefully removed 4 months earlier from a mid-size New Holland tractor after the machine suffered a catastrophic final drive failure that ruined the main rear axle assembly beyond economic repair. The auction house had held on to the power unit through the winter, finding that the local market for standalone New Holland diesels was much narrower than anticipated. The seller was eager to clear floor space before the spring rush and had lowered the reserve price to a fraction of its original appraisal value. Stepping over to inspect the unit, Ed pulled the shop paperwork attached to the front lifting eye. The plastic sleeve contained a verified compression report performed by the teardown shop prior to removal, showing high, uniform pressure across all 4 cylinders, alongside a clean visual inspection log noting 0 internal scoring, no metal debris in the oil pan, and no cooling system cross-contamination. He stood over the engine for 20 minutes with his notebook and a metal tape measure, running through the mechanical math. The New Holland 4-cylinder diesel featured a distinct layout compared to his original power unit, but its total displacement and horsepower ratings fell well within the operating tolerances of his John Deere transmission and hydraulic system. The flywheel diameter looked strikingly comparable, the front pulley alignment appeared workable, and the overall block length matched the engine bay envelope without requiring structural alterations to the main tractor chassis frame. It was an unconventional cross-brand pairing, but the fundamental engineering principles were undeniably sound. He negotiated a final purchase price that represented less than 25% of the lowest rebuild quote he had received, paid cash on the spot, and backed his pickup truck up to the loading bay to haul the heavy cast-iron diesel back to his farm. He backed his pickup into the heated shop, set the emergency brake, and hooked the overhead chain hoist to the lifting eyes of the heavy New Holland engine. Lowering it smoothly off the bed, he set the cast-iron diesel onto a heavy-duty steel rolling cart. In the center of the concrete floor sat the John Deere tractor, its front sheet metal removed, and its failed original power unit pulled back from the clutch housing, resting on wooden blocks nearby. For the first time, both engines occupied the same workspace, positioned side by side beneath the glare of the shop's overhead lights. Ed stood between them in the quiet room for a long moment, looking past the contrasting blue and green paint to examine the raw, physical geometry of the 2 blocks. What followed was a painstaking 7-day spatial assessment to determine whether an idea that made sense on paper could actually be executed in solid steel. Bringing out his precision dial calipers, steel rules, height gauges, and a fresh pad of grid paper, he began measuring every critical interface point down to the fraction of a millimeter. He started at the rear face of the blocks, measuring the diameter of the flywheel bolt patterns, the depth of the crankshaft pilot bearing recess, and the exact spacing of the bell housing bolt holes that mated the engine to the transmission input shaft. Next, he turned his attention to the front and side mounting points. The New Holland engine block featured a slightly different footprint across its mounting pads, requiring a precise offset calculation to ensure the engine centerline would align perfectly with the tractor's main drive shaft and hydraulic pump input. He measured the vertical distance from the bottom of the oil pan to the center of the crankshaft, confirming the front axle beam would clear the sump during full suspension articulation in rough field ruts. Finally, he mapped the accessory drive locations, tracing where the starter motor, alternator, steering pump, and main radiator hoses sat relative to the fixed interior envelope of the John Deere engine bay. Every single figure was verified 3 times. By the end of the week, his grid paper was filled with detailed dimensional sketches, proving that while no 2 factory mounting points matched directly, the physical space was wide enough to make the integration possible. With the physical measurements fully recorded, Ed cleared off his shop drafting table, unrolled a clean sheet of heavy grid paper, and began translating those raw numbers into clear working shop drawings. He did not rely on computer software or formal CAD programs. Instead, He utilized the practical drafting methods he had relied on for decades on the farm: a steel straightedge, a compass, a mechanical pencil, and an intuitive understanding of how structural metal behaves under heavy mechanical load. He sat under the warm glow of his desk lamp late into the evening, systematically solving every physical interface problem between the New Holland engine and the John Deere chassis on paper before striking a single arc with his welder. The first major hurdle was designing the transmission adapter plate. Because the bolt pattern on the rear face of the New Holland engine block was entirely different from the bolt circle on the John Deere bell housing, he designed a 3/4-inch thick steel plate to sit sandwiched between them. His detailed drawing specified precision, counterbore holes to secure the plate flush to the new engine block, alongside tapped holes positioned to accept the tractor's original bell housing bolts. He carefully calculated the plate's overall thickness to ensure the transmission input shaft would engage the clutch splines at the exact factory depth without binding against the pilot bearing in the flywheel. Next, he drafted the front engine support brackets. The factory John Deere side rails required custom-formed channel steel mounts, angled precisely to meet the New Holland side mounting pads. His drawings detailed heavy gusset plates to absorb the engine's severe torsional twist under sudden field loads. Beyond the structural frame, he mapped out the secondary systems on paper. The radiator connections required a custom upper coolant crossover pipe fabricated from mandrel-bent steel tubing to bridge the offset gap between the New Holland thermostat housing and the John Deere radiator inlet. Finally, he drew a swept exhaust manifold adapter, designed to route hot exhaust gases smoothly into the original underhood muffler, preserving the tractor's clean factory bonnet silhouette. Every drawing was checked against his measurements until he possessed a complete, actionable roadmap for the upcoming build. The practical construction phase began on a cold Monday morning, turning pencil lines on grid paper into load-bearing structural steel. Over 4 intensive days, the shop became a workspace of blue arc light, shower of grinding sparks, and the sharp scent of cut iron. Ed selected heavy half-inch steel plate and structural channel stock from his storage rack, laying out the precise dimensions with a steel scribe before cutting the pieces using his oxyacetylene torch. Each cut plate was ground smooth at the edges, removing slag and mill scale to ensure clean, flat surfaces for full penetration welds. The primary objective was constructing the custom side mounting brackets that would anchor the New Holland engine block directly to the John Deere frame rails. Positioned over the open tractor frame, the heavy New Holland diesel hung suspended from the overhead chain hoist, lowered millimeter by millimeter into the engine bay, using dial indicators and a magnetic digital level placed along the crankshaft nose. Ed adjusted the engine's position until the output shaft sat at the exact height, horizontal offset, and vertical tilt required for true alignment with the transmission input shaft. With the engine resting in this precise position, he tack-welded the initial steel plates to the frame brackets, verifying every spatial measurement against the tractor chassis. Thermal expansion from heavy welding can easily pull precise fabrications out of square, so he worked methodically, stacking short, alternating weld beads across opposite sides of the mount to distribute heat evenly and prevent structural warping. After laying down the final structural passes, he let the steel cool slowly under ambient shop air before grinding the seams smooth and flush. On Thursday afternoon, he slowly slackened the chain hoist, transferring the full 3/4-ton weight of the cast-iron New Holland engine onto his newly fabricated mounts. The structural steel held firm without a fraction of an inch of flex or deflection. Checking his alignment gauges one last time, the engine sat perfectly level along the frame's true center line, clearing the front axle beam and steering linkage while positioning the rear flywheel flush against the bell housing plane. The structural foundation was complete, ready for the mechanical interface to follow. While the frame mounts required structural strength, the transmission adapter plate demanded absolute mechanical precision. A misalignment of even a few thousandths of an inch between the New Holland engine crankshaft and the John Deere transmission input shaft would create destructive drivetrain vibration, quickly ruining the pilot bearing, clutch disc, and input shaft seals once the engine operated under heavy field load. Because his own farm shop lacked a heavy-duty vertical milling machine and a precision rotary table, Ed loaded his hand-drawn adapter plate schematics, measuring tools, and the bare John Deere bell housing template into his truck and drove 2 towns over to a local precision machine shop. The machinist was an old hand who had spent over 40 years turning steel for local agriculture and industrial operations. He laid Ed's grid paper flat across his workbench, studying the dual bolt patterns, counterbore depths, and clearance tolerances under a bright fluorescent lamp. For 2 hours, the two men stood side by side over the bench, comparing the drawings against the physical templates, double-checking hole center lines, and discussing the structural characteristics of the raw steel stock. The machinist checked the calculations for shaft engagement depth, confirming that Ed's proposed 3/4-inch thickness of high-tensile steel plate provided the exact spacing required to let the clutch pack operate smoothly without binding against the flywheel. Satisfied with the plan, the machinist clamped a solid slab of heavy structural steel plate onto the bed of his large vertical milling machine. Using a digital readout system to locate every hole coordinate with absolute accuracy, he bored the central recess to match the register lip on the New Holland rear main housing, establishing a true center point from which every secondary location was referenced. He drilled and counterbored the primary mounting holes to secure the plate flush against the New Holland engine block, then precisely located, drilled, and tapped the secondary bolt pattern designed to accept the original John Deere bell housing bolts. 5 days later, Ed returned to pick up the finished component. The completed plate was heavy, perfectly flat, and precisely machined, its smooth steel surfaces free of tool marks. Back at his shop, Ed carefully cleaned the rear face of the New Holland engine block, wiping down the raw cast iron with solvent until not a speck of dust remained. He lifted the heavy steel adapter plate into place. It slid smoothly over the hardened steel locating dowels, with a satisfying, airtight fit, seating perfectly flat against the engine block. He torqued the counterboard grade 8 fasteners to exact specification, watching the plate draw tight without a fraction of a millimeter of tilt. Now came the critical moment. Mating 2 massive pieces of cast iron from 2 entirely different manufacturers that were never intended to meet. Using his floor jacks and overhead hoist, Ed carefully rolled the tractor's rear chassis forward, lining up the John Deere transmission bell housing with the newly mounted plate. The shop grew dead silent except for the metallic click of the hoist chain. Hanging from the ceiling, the front half of the tractor swayed gently as he guided the heavy input shaft into the center of the New Holland flywheel. He paused, getting down on his knees with a flashlight to verify that the splines on the transmission shaft were lining up smoothly with the clutch hub. Step by millimeter step, he eased the chassis closer, checking that the input shaft slid into the pilot bearing without binding or catching on the splines. Suddenly, with a quiet, solid metallic thud, the John Deere bell housing met the adapter plate flush. The locating pins engaged without resistance, proving the machinist's precision and Ed's initial measurements were spot on. He reached in by hand and spun the rear PTO shaft to test clutch disengagement. The shaft turned freely, without a single drag or tight spot, confirming the input shaft wasn't bottoming out against the crankshaft. Working in a cross pattern, he threaded the heavy bell housing bolts into the tapped holes of the adapter plate, torquing each one steadily until the joint was completely locked. Stepping back to inspect the assembly, the blue New Holland engine now sat firmly bolted to the iconic green and yellow frame. The chassis rails aligned perfectly down the center, creating a single, rock-solid drivetrain ready to take on the secondary systems. With the engine firmly bolted to the transmission, Ed turned his attention to the cooling system, a critical phase of the conversion that left zero room for error. A diesel engine operating under heavy field loads generates intense thermal energy, and any restriction in coolant flow or air pocket inside the system would lead to rapid overheating. The challenge lay in the physical mismatch between the two cooling designs. The New Holland engine's thermostat housing and water pump outlets sat at completely different heights and angles compared to the original John Deere radiator connections. Over 3 long days, Ed systematically bridged this gap using custom-formed steel tubing, reinforced rubber hose transitions, and hand-fabricated mounting brackets. Outside the shop, the afternoon sun was melting the remaining snow cover, revealing damp topsoil and signaling that spring planting was rapidly approaching. Rather than using flexible universal radiator hoses, which could collapse under suction or kink in tight bends, he chose to fabricate rigid coolant crossover lines from heavy-gauge 2-inch steel pipe. Using a hydraulic pipe bender, he shaped the pipe to follow the precise inner contours of the engine bay, maintaining maximum clearance from the exhaust manifold and cooling fan blades. He welded custom mounting tabs directly onto the engine frame to support the weight of the steel coolant lines, preventing engine vibration from fatiguing the radiator solder joints. At each connection point, he machined a slight raised bead onto the ends of the cut steel pipes, giving the high-temperature silicone hose couplers a secure lip to clamp against under pressure. To handle the heater core circuit and bypass lines, he routed custom copper plumbing along the upper valve cover, securing the lines with rubber-insulated P-clips. He also integrated an auxiliary coolant air bleed valve at the highest point in the upper crossover pipe, ensuring that any trapped air could be easily purged during the initial fluid fill. On the third afternoon, he mounted the heavy John Deere radiator back into its front support frame, connected the newly fabricated upper and lower coolant assemblies, and tightened every stainless steel T-bolt clamp to specification. He filled the system with a 50-50 coolant mixture and pressurized the cooling circuit with a hand pump to test his custom connections. The pressure gauge held steady for 2 hours without dropping a fraction of a PSI, proving that every custom joint and weld was completely watertight and ready for the field. What remained was the critical secondary work, completing the exhaust plumbing, adapting the electrical system, and thoroughly preparing the fuel and oil circuits for the engine's initial start. Routing the exhaust system required careful sheet metal alignment to ensure the exhaust pipe passed cleanly through the original John Deere hood opening without scorching the painted bonnet. Ed fabricated a swept, mandrel-bent steel exhaust adapter that bolted directly to the New Holland exhaust manifold flange, curving smoothly upward to meet the base of the underhood muffler. He fitted a heavy-duty stainless steel flex joint into the horizontal section of the pipe, absorbing normal engine movement under load so that vibration would not crack the exhaust manifold studs or stress the bonnet sheet metal. Next, he systematically adapted the electrical wiring harness. Working with a multimeter and detailed wiring schematics from both manufacturers, he mapped out the charging, oil pressure, coolant temperature, and starter circuits. He soldered every connection, insulating each joint with double-wall heat shrink tubing to protect against oil exposure and field vibration, successfully integrating the John Deere dashboard gauges with the New Holland engine sensors so that every instrument reading would remain factory accurate. Finally, he executed the critical pre-start fluid protocols. He replaced the oil filter and filled the crankcase with fresh, heavy-duty diesel engine oil. Then, using a manual pressure tank connected directly to an oil gallery port, he pre-lubricated the engine, forcing oil through every internal passage, main bearing, and rocker arm assembly before the crankshaft ever turned over. He replaced the primary and secondary fuel filters, purged the low-pressure fuel lines, and operated the mechanical lift pump primer lever until clear, bubble-free diesel flowed from the bleed screws on the fuel injection pump. Checking the radiator coolant level and battery connections one last time, he cleared the shop floor around the tractor. Every wire was tied off, every line was double-checked, and the hybrid machine sat fully prepped, plumbed, and ready for its first start attempt. Saturday morning arrived with a clear sky and cold, still air hanging over the farmyard. Inside the shop, the silence was heavy, broken only by the faint hum of the overhead fluorescent lights and the rhythmic click of his manual fuel priming lever. Ed stood beside the green utility tractor, his thumb resting on the cold steel lever of the lift pump, working it steadily until the resistance hardened and a sharp metallic hiss confirmed that the fuel injection pump was fully charged with bubble-free diesel. He wiped his oil-stained hands on a shop rag, stepped up onto the footplate, and settled into the driver's seat. He paused with his hand on the key, his eyes sweeping across the instrument cluster. The mechanical oil pressure gauge, the newly wired coolant temperature needle, and the voltage meter all sat motionless at 0. He pushed the hand throttle forward a 1/4 inch, took a deep breath, and turned the key to the ignition point. The starter solenoid clicked. The starter motor engaged the flywheel teeth with a sharp mechanical thud, and the heavy engine began to roll over. The starter turned the engine through 3 slow compression strokes before the cylinders caught. A thick plume of gray exhaust shot upward from the bonnet stack, and the New Holland engine burst into life with a loud, irregular clatter that echoed off the shop's steel walls. For the first 60 seconds, the engine idled roughly as cold diesel fuel burned unevenly across the unheated cylinders, and the mechanical governor hunted slightly, while fresh oil worked its way through the tight clearances. He kept his hand near the emergency fuel shutoff rod, watching the gauges with focused intensity. Within 2 minutes, the sharp mechanical chatter began to smooth out into a steady, rhythmic thrum. The needle on the mechanical oil pressure gauge rose smoothly, settling right at 55 psi. The gray exhaust smoke cleared completely, replaced by a faint, clean haze. As the coolant circulated through the newly fabricated steel crossover pipes, the temperature gauge crept steadily upward, leveling off right in the center of the green operating range. The custom engine mounts absorbed the vibration perfectly, keeping the tractor chassis steady. Sitting in the cab, listening to the deep, steady idle of the New Holland engine inside the John Deere frame, he knew the mechanical gamble had paid off. On Tuesday morning of the following week, Ed backed the modified tractor out of the shop and drove it 3 miles down the county road to the regional John Deere dealership. The morning air was crisp, and the hybrid tractor ran smoothly, the New Holland engine humming steadily under light road travel. He was not visiting the dealership to show off his mechanical accomplishment or seek approval. He simply needed a routine set of replacement O-rings and lip seals for the tractor's rear hydraulic remote valves, a standard maintenance kit for a component that was entirely factory original and had nothing to do with the recent engine swap. During the short drive, he kept a close eye on the dashboard, noting that the coolant temperature remained perfectly centered in the operating zone while the oil pressure held rock solid. He pulled the tractor into the paved parking lot along the side of the dealership's main service building, idling the engine for a moment to let the turbo cool before shutting it down. Walking inside through the glass front doors, he headed directly to the long parts counter at the back of the showroom. The counterman, a familiar face who had worked at the dealership for over a decade, nodded in greeting as Ed took a seat on the stool. Ed reached into his coat pocket, pulled out his worn shop notebook, and read off the tractor's factory serial number, alongside the specific part number for the rear hydraulic seal rebuild kit. The counterman entered the 17-digit serial number into his computer terminal. The keys clicked rapidly under his fingers, then suddenly stopped. He stared at the monitor, his eyebrows furrowing slightly as he scanned the screen line by line. A flag or note in the central dealership database had appeared alongside the machine's profile. The counterman leaned closer to the screen, typed another command, and then paused, resting his hands on the edge of the counter. Without saying a word to Ed, the counterman stood up, turned around, and walked down the short hallway behind the counter, directly toward the service manager's office. Through the glass window of the office door, Ed watched the counterman point back toward the front counter while explaining something to the manager. The service manager listened intently, pulled up a record on his own desktop monitor, and spent several minutes reviewing the file. The entire interaction took nearly 10 minutes, a long, quiet stretch of time during which Ed sat calmly at the counter, fully aware that his simple parts order had triggered something far beyond a standard counter transaction. The service manager walked out from behind the counter, holding a printed paper in his hand. He greeted Ed politely, using his first name in the quiet tone of a man delivering difficult news. They had known each other across that counter for nearly 2 decades, back when Ed first brought the utility tractor in for its initial secondary inspections. But as the manager rested his hands on the laminate countertop, his expression was firm, governed strictly by corporate dealership protocol. He explained that the company's corporate network had recently implemented strict liability guidelines regarding equipment operating with non-standard power units. When the counterman entered the tractor's serial number, the system flagged a field report noting that the original engine was unserviceable, and local word had reached their service desk that the machine was now running a New Holland engine mated to the original John Deere transmission. Under their franchise agreement, supplying factory components for a machine operating outside original manufacturer specifications created severe liability, warranty, and corporate policy complications. Ed listened quietly, pointing out that the hydraulic seals he requested were factory standard parts for an unmodified hydraulic pump that had been on the tractor since it left the assembly line. He asked how an internal engine swap affected a simple rubber seal on a rear hydraulic remote valve that operated on the exact same hydraulic pressure as it always had. The service manager acknowledged the logic of the argument, admitting that the hydraulic system itself was completely unchanged, but explained that corporate policy made no distinction between individual subsystems. Once a machine's primary power source was replaced with a non-brand unit, The dealership's franchise license prohibited them from selling any structural or hydraulic parts for that specific serial number. He delivered the refusal calmly, emphasizing that it was not a personal decision, but a mandatory policy he was required to enforce. Ed didn't argue or raise his voice. He simply nodded once, thanked the service manager for his time, and walked out to his truck. The refusal at the dealership counter was an inconvenience, but it was far from a fatal blow to Ed's planting season. Sitting in the cab of his pickup, he pulled out his phone and dialed an independent agricultural supply warehouse, 2 counties over, a family-owned business that specialized in heavy machinery seals, hydraulic fittings, and universal farm equipment replacement parts. He read off the dimensions and part numbers for the hydraulic spool valve seals to the counter salesman. The independent supplier confirmed they had the exact seal kit in stock, manufactured by the very same commercial hydraulics firm that supplied the original equipment manufacturer. Better yet, because the independent warehouse operated without the steep retail markups of a brand-name dealership, the complete seal kit cost nearly 30% less than the dealer's quoted price. He ordered the parts on the spot, arranged for overnight shipping directly to his farm, and drove home with the quiet satisfaction of a man who had successfully navigated around another corporate roadblock. The parcel arrived on his porch the following afternoon. Ed brought the heavy rubber seals out to the shop, slid them into the hydraulic remote valves, and torqued the retaining caps down to factory spec. With the hydraulic system fully sealed and pressurized, he backed the hybrid tractor over to his implement shed and hitched it to his heavy 24-foot tandem disc cultivator. As he connected the hydraulic hoses to the rear remotes, the cylinder shafts extended smoothly, without a single drop of fluid leaking past the new seals. He checked the engine oil level, inspected every custom cooling bracket, and topped off the main fuel tank with clear diesel. Outside, the fields were dry, firm, and ready for work. The machine was prepped, proven, and standing by for the ultimate test in the soil. At sunrise on Monday morning, Ed dropped the heavy tandem disc deep into the dark, damp soil of his front 40-acre section. As he brought the hand throttle forward, the New Holland engine responded with a deep, authoritative roar, digging in its heels and pulling the heavy tillage implement through the earth without a single hesitation. The mechanical match was flawless. Across the next 3 weeks, the hybrid tractor worked tirelessly through 600 acres of spring ground, working 12-hour days pulling the disc, harrow, and 16-row planter through tough, unyielding clay. Ed kept a watchful eye on his custom dashboard gauges, but the needles stayed locked in their safe zones. The oil pressure remained steady at 55 psi under heavy load, and the custom steel cooling lines kept the water temperature perfectly centered, even during the hottest afternoons. To his surprise, the New Holland diesel turned out to be remarkably efficient, burning nearly 15% less fuel per acre than his old worn-out power unit had during the previous season. As the last field was planted and the sun dipped below the horizon, Ed throttled down near the edge of his property, listening to the smooth, steady idle of the blue engine housed beneath the classic green hood. His hard work, precision engineering, and refusal to surrender to expensive dealer quotes or corporate rules had paid off. He hadn't just saved his farm thousands of dollars. He had honored his land, preserved his independence, and proved that true craftsmanship and practical problem-solving will always trump corporate gatekeeping. If you enjoyed this story of American grit, mechanical engineering, and farmer resourcefulness, please hit the like button, share this video with someone who appreciates hard work, and subscribe to the channel for more authentic stories from the heartland. Thanks for watching, and we'll see you in the next one.